Okay, so today we're going to do exam 2, and so we're going to just jump right into it. I'm assuming I have a student number of 7654321. Okay, so let's go over here. To turn the moment of F1, so this one's F1 right here, around the point O. Okay, now F1 is given, according to my student number, as 113 in the I direction, minus 174 in the J direction, plus 75 in the K direction, and that has units of pounds. Okay, so finding the moment here is almost mindless in some ways. It is ultimately boils down to finding the determinant of this matrix, I, J, K. Okay, so basically the moment equals R cross F. Okay, so the R vector in this case is in the X direction, we're going 4 feet. In the Y direction, we are going, that looks like 5 feet. And in the Z direction, we are going 3 feet. Okay? And then my force in this case is 113. Oh, let's give ourselves a little bit of space there. 113 pounds. Negative 174 pounds, and 75 pounds. Okay, and there's a few ways to get that determinant. I usually like to just draw out the next 2 lines if this thing were to continue, and basically I'm just going to copy the other ones. Jeff Hansen likes to do the I think it's called the Kramer Rule. You could do that too. It's fine. 113 pounds and negative 174 pounds. Okay, so as I conduct the calculation here, I'm going to move all of my units till the end. So let's see here. So we're going to go right here. 5 times 75 is 375. Let's see here. 3 times 113. That's 339. And negative 174 times 4 is negative 696. That's a K. Okay, now we'll have negative signs for these. So minus 113 times 5 is minus 565, and that has a K. Okay, 3 times 174, that's negative, but then it gets negatived again, so it becomes positive. Plus 3 times 174 is 522, and that has an I. And then this will have a negative, so that'll be minus 4 times 75, which is 300K. Oh, sorry, J. Anyway. Okay, J. Okay, so, and the units on this, which I decided to move to the end, are foot-pounds. Okay, and sometimes they're written pound-feet, but I think foot-pounds is much more normal. So what we're going to do here is we're just going to gather like terms. M naught equals, let's see, in the I direction, we're going to take this I right here, and we're going to combine it with that one. And it looks like my key, which I posted already, has an error right there, but that's okay. 897 in the I direction. And then let's see, we're going to gather these J's together, and they're going to add up to, 39 in the J direction. And then the K is, which adds up to the biggest number here, which is 12 minus 12, 61K. Okay, and again, that has units of foot-pounds. So if you're asking how I'll grade this, basically, looking for do you understand what we're doing, like the formula here? And there's a few different ways you could have done this, obviously. You could have done this with perpendicular distances if you wanted. I think that doing it this way would have been the easier way, but as long as you present some kind of way that makes sense. And then once you do that, basically each one of these numbers is worth a point. And it just shows you're multiplying the things the right way, and that point includes the sign. And then this final answer is worth 2 points. And obviously you could get a different final answer, like, obviously if you say you mess up right here, you could get a wrong final answer. But basically what I'm asking for here for these 2 points is, did you combine these things correctly? Did you leave the I, J's, and K's? And did you give me the units? Okay, so So that's how we do this one. So that's 10 points on that. Okay, so let's go over here and let's do the second one. Oh, it looks like I kind of wrote in that space a little bit. So determine the force in each cable necessary to support the load. So I think in this case, my load is 571 pounds, which is a most unfortunate number, but whatever, right? It's just 571 pounds, 571 pounds. Now what's nice is if we look at this one right here, this triangle, this is a 3, 4, 5. The 6 is the 3, the 8 is the 5, so this is at 10 feet. So that's good, that's helpful. That should make things a little easier. If you want to, you could use the angle here, so you could solve for that angle and you would get 53.130 degrees. I'm going to choose not to use that because I don't feel like it, because it's just, I think in my official key that I posted, yeah, no, I did not. I used the sides of the triangles because it's easier. Okay, so here we've got a 2, we've got a 6. Okay, you could, if you wanted to, go out and solve for that angle, and you would 18.435, 18.435 degrees. I did not do that. I said, well, 6 squared equals 36. 2 squared is 40, or plus 2 squared gives me to 40. So this side is square root of 40. Okay, I prefer my similar triangles. Okay, so that's the way I'm going to do this one. If you want, I can show you how to do it like this if you don't like this, okay? So we're going to start here, and I'm going to say, okay, the sum of the forces. So we're going to go in directions, and the x direction is a nice direction to start. Obviously, you can start with a different direction if you prefer. Okay, so the x direction is positive in this direction. Okay, so the only force we have in that direction is the x component of AC. So that's going to be AC, okay, which is the diagonal. So the square root of 40. Okay, and I want the x component, so it's going to be 2 over the square root of 40. Okay, and then I've got this negative component, which right here, that's the BC. Okay, so it's going to be minus BC. And of course, it's the square root of 40 as well, divided by the square root of 40. And 2, because I want the portion that is in the x direction, equals 0. So ultimately, what you're going to get out of this is that AC equals BC. AC equals BC. Sweet. All right, so now we're going to go, the next easiest, I think, is the Z direction. Why? Because there's only 2 forces in the Z direction. Okay, so sum of forces in the Z direction equals 0. Okay, and I've got that weight, negative 571 pounds. And then I've got the vertical component of CD, right? So plus CD, okay, and it's acting along the diagonal, but I want the vertical component, so we'll do like that. Okay, and that equals 0. So for this particular solution, CD equals 713.75 pounds. Boom. Okay, so now we're getting somewhere. All right, so now let's see if we can't get, okay, so we've done X, we've done Y, Z, so then Y is going to be next. Sum of the forces in the Y direction equals 0. Okay, so the Y direction is going this way. That's the positive Y. So it looks like we've got all of our cables working against each other here. So let's start with DC, or CD, because that's the positive one. CD. Okay, and we've got the 10. Because that's CD. And then we want the 6 side of that, so we'll do that. And then I'm going to subtract, well, let's see here, BC, because BC is acting in this direction, right? So that's a subtract. So that's BC. We've got the diagonal, and we want the 6-foot side, so we'll do like that. And then we'll do the same for AC. Okay, both of those are acting in the negative Y direction. AC, we've got the diagonal, and we want the Y direction side. And granted, again, you can do all this with sines and cosines if you wanted to, but I don't like that. Okay, so there we go. So what's cool here is, well, we already know CD from right here, so I can plug that in. And I know AC equals BC, so I can get rid of one of my terms there. So in other words, I have 6 out of 10. CD is 713.75 pounds. Okay, minus. Now instead of having 6 over square root of 40 BC and 6 over square root of 40 AC, I'm just going to turn one of those AC or BC into the other because they're equal. So let's make this like a BC here, right? And so now I've got 2 of those. So that's going to make it minus 12 over the square root of 40 times BC equals 0. Okay. So if I can solve for that equation, I can say that BC equals 225.71 pounds. And then that means that AC equals 225.71 pounds also because of this equation up here. So there we go. And that's how we solve. Okay. And if you want to know how I would grade this, I would look at this and I would say, well, what matters to me is that you're getting these equations right. So let's see. So this equation, is worth 2. Okay, this equation is worth 2. This equation is worth 3 because it's got 3 terms. So basically, plus 1, plus 1, plus 1. So plus 1, plus 1, plus 1. Okay. And then, well, we've got our, let's see here. This answer is worth 1. This answer is worth 1, 2, 3, 4, 5, 6, 7, 8, 9. Where's my last? Oh, is this one right here. So basically the 3 answers are worth a point apiece. And then, yes, and then the equations are worth 2, 2, and 3. Okay. So there you go. So that's how we do that one. So that one's worth out of 10. Okay. Because I know that this one's going to be the longest, we'll come back to it in a second. You know what? Let's just do it in order. Let's see. What was my P? So with my specific numbers, P here is 13 kilonewtons. Oh, I don't want red. Red is for grading. Red is like the mean color. I really hate the mean color. This is 13 kilonewtons. Okay, this angle is 44 degrees. 44 degrees. Okay, and so I'm just going to go ahead and split that right now into 2 forces because I don't ever want to think about 13 kilonewtons and 44 degrees. So if we split this, I got 13 sine 44, which comes to 9.0306 kilonewtons. Okay, that's a lot of sig figs. And then this side, which will be 13 cosine of 44, which is 9.3514 kilonewtons. Okay? All right, so the first thing we need to do here is I need to go ahead and get my external reactions. So here we go, reactions. Okay, so to do these, let's see here, I've got one here. I'm just going to call that C. And then it looks like I've got a GX, or GY, excuse me, and a GX, right? And I'll probably erase those and give them different signs depending on how I want to do it. Okay, so let's see. The easiest thing here is going to be the horizontal. All right, so let's go ahead and do that. The sum of the forces in the x direction equals 0. So I've got GX plus this 9.3514 kilonewtons equals 0. So GX equals negative 9.3514 kilonewtons. Okay, good. Okay, so I'm going to go ahead and erase this one because I don't like looking at it I don't like negative numbers. So I'm going to put it going like this. So 9.3514 kilonewtons. I'll make note that GX equals 9.3514 kilonewtons going this way. Okay, cool. All right, now I need G, Y, or C. Either one of those can be gotten with moments. Neither one of them can be gotten with the sum of forces in the Y direction because they're both in that direction. So let's do the sum of the moments. Sum of the moments in the Z direction. And let's do them around, it doesn't matter which point here. Let's do them around G. Just because I kind of like doing it around endpoints. It just kind of like I don't know. Makes all my distances a little bit easier to think about. So we'll start with that 40 we're going to start all the way over on the left, and we've got 40 kilonewtons. Okay, and its distance is 6 plus 6 plus 6, so that's 18 meters. Okay, and it looks like it's going to cause things to spin counterclockwise, so we'll make that positive. Okay, and then I'm going to do the plus 9.0306 kilonewtons times 6 meters plus half of this 6, which is going to be 3 meters, so that's going to be 15 meters. Okay, and that's going to spin the same direction as the last one. Then 9.3514, on the other hand, is going to cause things to spin clockwise. So we're going to go minus 9.3514 kilonewtons. And its distance is 4 meters. Okay, so I'm going to keep going. We got C, which is going to cause things to go clockwise. So we go minus C times 6 times 6. That's 12 meters. Okay, now we've got this 80, which is going to cause things to go counterclockwise. 80 kilonewtons. Okay, times 6 plus half of 6, which is going to be 9 meters. Okay, now this was my mistake on this problem, was all these forces just ended up taking a lot of time that didn't really show that you knew any more than you might have otherwise. So this was my error on this problem. And then so we've got this 100 going down. So that's also going to cause things to go counterclockwise. So we're going to go plus 100 kilonewtons times just those 6 meters. And that's all my forces, equals 0. And it looks like I have another small error that I'm going to have to come back and fix. But hopefully you guys are not looking at that right now. I will remove it in a second. So 178.17 kilonewtons. Okay, that's C. Okay, so now we have to get G in the Y direction. And the only way I don't really want to go over there yet. So G in the Y direction. So we'll do sum of the forces in the Y equals 0. We could also do another sum of the moments if I wanted to do it around C. But summing forces is usually less error prone than doing moments. So it's usually a good idea to do it that way. So in the Y direction, let's see, we've got negative 40 kilonewtons minus 9.0306 kilonewtons plus C, which is 178.17 kilonewtons. In fact, let's go ahead and put that on there. If it will let me erase, it will. Come on. You can do this. Okay, 178.17 kilonewtons. Okay, minus 80 kilonewtons, minus 100 kilonewtons. Why does it keep blurring? Plus GY. Plus GY equals 0. So we'll say that GY equals 50.861 kilonewtons. Okay, so there you go. Okay, and I'm going to go ahead and put those on my drawing because I don't particularly want to, I don't want to look at this GY. Okay. All right, so now we will attempt to work this problem to solve CD, DE, and DF. I'm going to switch to black for those. But we'll note that CE is right here, DE is right here, and DF is right here. So my free body diagram is everything on the right-hand side of that line. And so I'm going to replace these things with forces, and I like to assume everything is in compression. So here's my compression members. So if I get negative numbers, that means it's in tension. So this is going to be DF. This one will be DE. And this one will be CE. Okay? So now the whole rest of that thing does not exist. And let's see, how should we solve this? Well, the x direction is problematic because I've got all three of those unknowns are in the x direction, so we don't want to do that. The y direction only has DE in it, or is an unknown, so that's pretty good. So let's go ahead and do the y direction. Okay, so we're going to call this the members, or the subsection, or whatever you want to call it. And so let's start in the y direction. The sum of the forces in the y direction equals 0. So I've got DE going down, DE going down. Now, when you think about these triangles, they're all the same. Okay, note that this is a 3, 4, 5 triangle. So for DE, right, I have the diagonal, which is a 5. But I want the vertical, so this is going to be the 4. Okay. Now note, of course, you can solve for this angle, and you will get 53.130, as we always do. We have a 3, 4, 5 triangle, unless you get the other angle, in which case you'll get, what is that, 36.87 or whatever it is. Anyway, so that's going to be a negative force. What else do we have in the y direction? We've got a negative 100 kilonewtons on our section. And it looks like we've got a plus 50.861 kilonewtons. Okay, if we add all those up, equals 0. Okay, so let's go ahead and solve that, and we're going to say DE equals, okay, some fancy number, 61.424, and underneath that I can say, well, DE equals 61.424 in tension, kilonewtons in tension, right, because that's kilonewtons in tension. Okay, and so over here for DE, I would go ahead and circle tension, and I would say 61.4 kilonewtons, okay, because we only want 3 sig figs. All right, cool. All right, what else can we do? Okay, the x direction is still a little bit fraught, so maybe we want to avoid that. But let's do some moments, maybe. Moments seems very useful. I think in my key, let's see, on my key I did the moments around E, which is a possibility. You could do it here. However, now that I have DE, you know what, I don't want to deal with DE. DE is on a diagonal. So let's go ahead and do it around E. Okay, I don't want to do a diagonal because then I have to do it with 2 forces, right? So let's see what we can do here. So this, well, let's see if we can zoom down here, and we'll just say sum of the moments around in the Z direction around point E equals 0. Okay, so let's see what we have. CE is not in this equation. This is not in this equation. This is not in this equation. DE is not in this equation. This is not in this equation. So all I've got is DF right here. Okay, and it's got a moment arm of 4. So DF times its moment arm of 4 meters. And that looks like that's going clockwise, so we're going to make that negative, right? Because it's going clockwise around E. And then we just need this 50.861. Okay, 50.861. Okay, and that's going to go counterclockwise, 50.861 kilonewtons. Okay, and it's got a moment arm of 6 meters. Oh, come on, you can do this. Okay, times 6 meters. Okay, so we can solve this, and DF basically looks like DF is going to be 1.5 times that G in the Y. Okay, so it's 76.292, and that's positive. Okay, so I don't need to write this twice. I can just say, oh, look, it's compressive. Cool. We like compressive forces. Those are positive signs, okay? So over here for DF, I can go ahead and say this is compressive and say it's 76.3. Okay, so now that I've done that, I could sum forces in the X if I wanted to, and maybe that's the best way to go here. So X direction forces, let's see, we've got CE, I've got DE, I've got DF, and I've got this one. Okay, so that's a few more forces than we wish we had. But, you know, that's how it goes sometimes. So sum of the forces in the X direction equals 0. So I've got, I'm going to write these out in symbols, CE. That's the one we're looking for. DE, which is actually negative. So DE, but it's on a diagonal, right? So it's on a diagonal, and the X direction is negative because there's a negative sign right here, so I drew it the wrong way. And we have the diagonal, 5, but we want the horizontal, which is a 3. Okay. And then what else do we have? DF. plus dF. Okay, and then we're going to subtract that 9.3514 kilonewtons equals 0. Okay, so once we do that, everything I have is down here. Let's see here. CE is what we're looking for. CE minus, well, 0.6 times DE, which is 61.424 kilonewtons, plus DF plus 76.292 kilonewtons minus 9.3514 kilonewtons equals 0. Okay, so now we just need to do some algebra here. CE equals negative 30.086 kilonewtons, or 30.1 kilonewtons in tension. Okay, so CE equals 30.086 kilonewtons in tension. Okay, boom. All right, so that was kind of the mistake on this thing. This one took a little bit too much time. Okay, so let's go to this one. Determine the force in every member of the truss below. Do not forget to indicate if the member is tension or compression. Okay, so to help you remember, of course, I put this down here. Anyway, okay, so let's look at this thing. P, in my case, is 675 kips. 675 kips. All right, so we've got a few external forces which we want to deal with. I'm going to go back to blue because blue it kind of just shows up better in a black and white world. Okay, so we've got CY is right here, CY, we've got CX. Okay, and we've got I'm just going to call it A. Now in this case, you could actually probably get it by without doing the external forces first, but it's always a good idea. So let's just go ahead and get them. Okay, so the sum of the forces in let's do the x direction. That looks like the easiest. So I've got CX is in the positive, minus 675K equals 0. So CX equals 675K. Cool. All right, let's go ahead and erase that, and let's put in a 675K. Okay, now we've got CY and A, so we got two of those, so clearly it's not going to be all that useful to sum forces in Y, so let's do the moments. Sum of the moments, and let's do it around point C. Okay, so this will be in the Z direction around point C equals 0, so this is the point we're going to do. Okay, so that only leaves two forces. So it's going to be 675 kips times its moment arm, which in this case is 4 feet. Which way is that going to cause this thing to spin? It looks like it's going to go counterclockwise. Yeah, counter. So we'll make that a positive. Okay, and A is going to go the other way. So minus A times its moment arm, which is 4 feet plus 4 feet, which is 8 feet, equals 0. So A looks like it's going to be half of that 675. So A is going to be, what is that, 387.5, I think? 337.5. Sorry. All right, so there you go. There's A. All right, so now we have to figure out, let's do the sum of the forces in the Y. Let's just do it over here. Sum of the forces in the Y equals 0. Okay, and we've only got CY and A. So CY plus A equals 0. So CY plus 337.5 kips equals 0. So CY equals negative 337.5 kips. Okay. So let's take this CY and let's see what we can do to get rid of it. And let's have it point in the direction that it actually goes in. So we're going to draw this little thing right here. And we'll call that 337.5 kips. All right. So now let's start looking at the forces here. Oh, I didn't get Y. A did I? Okay, I need to do the same thing there. So 300, and come on, 300, it's going to freeze for 8 seconds, 337.5 kips. All right, so we're going to just stare at this. One thing that we want to note right off the bat without doing any work is that this is the zero force member right here. Okay, how do I know? Because if we look at joint B, you'll see that it's the only force in the y direction. Okay, so if I sum forces in the y direction on B, it's going to come out to BD plus nothing, or just BD equals 0, because there's nothing else there. So, so right off the bat, we can say that BD is 0. So we go down here, BD, 0. Okay. All right, so that greatly simplifies things. Okay, but what I'm going to do is I'm going to start out at this. I'm going to start out at A, and I'm going to do this the way that I solved this. Okay, which is, okay, I've got a vertical force of 300. So if I sum forces in the y direction on this one right here, I've got 337.5 going up. I need 337 going down. I can only get that from this member right here, because it's the only one with a vertical component. So this is 337.5 going down. Okay. Now I want to keep in mind this triangle. Okay, if we zoom out, it's a 4, 4. Which means really this is a 1, 1, right? The ratio of sides is 1 to 1, and this one is the square root of 2. Okay, so if the vertical is a 1, the horizontal also has to be a 1. So this is going to be a 337.5 kips. So this is looking like this. And I'm going to take that 337.5, 337.5, I'm going to multiply it by the square root of 2. And I'm going to get 477.30. 477.30 kips. Okay, so it's pushing, so that's compression. Okay, so it's got to push on this side as well. 477.30 kips. Okay, and it's the same triangles down there. So I'll go ahead and draw it like this. And that's 337.5 kips in the x and 337.5 kips in the y. All right, cool. All right, so that was so now I've just balanced my sum of the forces in the y. Check, because I've got 337 going up there and 337 going down there. Okay, I've got this 337 going to the left. So if I want to get the sum of the forces into y, the x to balance, I need 337.5 going this way. 337.5 kips going that way. So now I've balanced the x direction. Okay, so that's coming into here. Okay, so this thing is pulling. So this is tension. Oh yeah. This one's compression. Okay. So now we're going to go to this joint right here, and I want to say, okay, the sum of the forces, I'll just go ahead and ascertain. So if I say the sum of forces into y equals 0, well, this force is not being balanced by anything, so it has to be equal to 0. So this force is a 0 force. Okay, I could put arrows if I want to, but they're kind of meaningless. Okay, now I want to sum forces in the x direction. And let's see, so I've got 337.5 going to the left. So I need that same amount going to the right. So 337.5 kips to the right, and that's in tension. Okay, so there you go. Sweet. All right, let's go up to this top one. I've got 675 kips to the left. Okay, so let's go by directions here. Sum of the forces in the x direction equals 0. Okay, so I've got 675 to the left. I've got 335 to the right, which means that this one has to hold the remainder, the difference between those two. So if I pull out my trusty dusty calculator and I say 675 minus 337.5 is 337.5. So I got 337.5 going to the right. Okay, again, remember this triangle is a 1, 1 square root of 2. So that means going down right here, I need to have 337.5 because they're both on the one sides. And then I need to multiply by the square root of 2, which is going to give me 477.30 kips right here. Sweet. Okay, which means I've got the same thing over here, 477.30 kips. Okay, and I got, which boils down to a 337.5 kips and a 337.5 kips. Okay, so these are both pulling, so this whole thing is in tension. Okay, now just to check it, we go down to this bottom one right here, and we'll say, okay, do the things in the x direction add up to 0? Well, let's see here. I've got 337.5 here, I've got 337.5 there, and I've got 675 there. So those all add up to 0. Okay, now what about the vertical? Sum of the forces in the y direction equals 0, and we've got 337 down, and I got 337 up, so those check out. Okay, so now we just got to go down here and, you know, fill those in. So right here I've got, let's see here, AD is 477.30 in compression. Come on, you can do it. AD, 477 point, well, I guess we're just going to stop there. That's in compression. Similarly, CD is 477, but it's in tension. Okay, and then the two along the bottom are both in tension, and they both have 338. Yes, I know we had to round. Okay, and we need units on that, so it'll be kilonewtons. Oh, not kilonewtons, kips. Kips are my favorite because they're the easiest ones to write down. Kips, 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 kips. We like kips. All right, so when I took this, it took me 27 minutes and 10 seconds. It should have taken me 25 minutes for this to be a fair test, because normally what I do is I take the amount of time it takes me to do it, I multiply by 3, and that gives me the hour and 15 that you need to take the test. Okay, and then of course you get the added, because we're online this semester, you get an added 30 minutes, you know, just to, you know, for technical difficulties, but most of you choose to use that time to take the test. But anyway, regardless, so if I instead I multiply this by 3, and I got 81 minutes and 30 seconds, okay, which is too long, right? So let's make this 75 minutes. So how long was I? So basically I'm going to create, so what I'm going to do is, this test was out of 55 points, but it's not going to be out of 55 anymore, and I need to know how much to make it out of. So 81.5 minutes instead of 75. Okay, so that's how long I was, basically. I was this much too long. So that's too many points I asked you to solve for. So we'll cross multiply that, and we'll say that equals 50.6. So I should kind of do this out of 50.6 points, but instead I'm going to do it out of 50 points. Okay, because I think that's, you know, so basically, so instead of grading this out of 55, I'm going to grade it out of 60 points. Oh, I forgot how I'm going to grade this one. So typically, if you look up here, it says 5 points each. So how am I actually going to grade this one? Each one of these is, in fact, worth 5 each. However, you couldn't get any of these, but you could get, let's suppose you just got these. I haven't done this yet, but this will probably be worth 10 if you got it without getting into the nitty-gritty, even though I don't know if I'm going to make it worth 10. Anyway, this was not the point of this question, obviously. So, but, you know, I didn't make it too long, so there is that problem. Okay, over here on this one, you know, I didn't talk about how I was going to grade this one either. But basically, your reactions are each worth 1 point. Yeah. And then, oh, I guess I should have defined the directions for these. C is up. GY is up. Anyway, so then if I go down here, that leaves me with, basically I'm looking for your equations here, plus 2 for this equation, plus 2 for this equation, and plus 2 for this equation. Okay, and then just getting the tensions and compressions are worth a point correct here. Okay, so that's pretty much how I'm going to grade that one. Okay, and that's probably what I'll be doing all evening and most of tomorrow. So, yeah. Anyway, hopefully this was helpful, and that's it. So take care of yourselves. All right, goodbye.